Now we shall discuss about the various types of motions that a body is capable of and how we deal with them mathematically, how we get their equations, what are the corresponding graphs associated with those motions. All that we shall be studying as the next topic now. So, starting from the very first and the basic most type of motion, which we call as uniform motion. Uniform motion is that motion in which a body moves uniformly, as the name suggests. So, it travels in one single direction along a single straight line and with a constant speed, so that it travels equal distances in equal intervals of time. So, if a body is moving with a constant speed v in one single direction, whatever that direction is, do we understand that in that case the body will have a constant velocity, because velocity incorporates both the things, the speed and the magnitude of velocity as well as the direction, right? So, we say that in case of a uniform motion, the velocity of a body remains a constant. This is the defining condition for uniform motion. Right? So, the body will move in one single direction with one single speed. Do we understand that if there is no change in the velocity as the body proceeds, it is not suffering any acceleration? Because acceleration by definition is the rate of change of velocity, precisely saying it is dv by dt, rate of change of velocity. Since there is no change happening in the velocity, we can comfortably say that this value must be 0. So, a body in uniform motion will always have a 0 acceleration associated with it, since there is no change in the velocity, right. So, in that case, what kind of motion will the body will have, like what distance will it move within certain intervals of time, and how its motion will look like. We can start by taking up the expression v is equal to ds by dt, which is the defining expression for velocity. It is the rate of change of displacement covered by a body. That is what v is, velocity is. From this equation, see that we can write ds is equal to v into dt. What is this expression? It tells us that a small displacement covered by a body in any small interval of time dt is the velocity v at that time multiplied by the interval dt, right. So, this is like displacement is equal to velocity into time, general expression, but for a very small interval of time dt. Now, so if we have to find out the total displacement that a body covers, we need to add these small displacements ds and get the total displacement. Addition of these small displacements mathematically is called nothing but integration. So, the total displacement s, which will mathematically be the integral of ds, should be equal to the integral of v dt. We should add the small product of v into dt as well to get the total displacement. Now, from the rules of integration, within the integral, if we have a constant factor, it can be taken out of the integral, it will not affect the integration. So, we can take the velocity v out and we can just integrate dt, right, to get s. So, understand that when we integrate dt, what we will get will be a total time interval t in which we are trying to find out s, the displacement. So, from here we can write s is equal to v times t simply, right. This is an equation of the form, if you see carefully, this is an equation of the form distance is equal to speed into time. Here it is displacement is equal to velocity into time. So, such an equation will be valid for a uniform motion. When a body moves uniformly, we can simply find out the displacement covered by a body by multiplying with the velocity with the time in which we are looking for the displacement. So, this is how the motion is when a body moves uniformly. Its acceleration is 0, the velocity is a constant, and as we can see, the displacement covered by a body will increase as the time increases, because v is a constant. As t increases, s will increase linearly, proportionally to the time. right? The greater the interval of time, the greater will be the displacement of the body. Once we understand this, now we can try drawing the graphs corresponding to various quantities as a function of time t. So, the standard graphs that we try to study in case of studying any motion, right, are graphical representation. Now we are discussing for uniform motion. So, we say that the basic graphs that we would like to see here would be, one will be the acceleration versus time graph, how the acceleration of the moving body varies with time. We would also like to see the graph of velocity versus time, what is the relationship of velocity with time t, and we would also like to see the variation of the displacement covered by the body as the time progresses. So, in the first case, do we understand that the acceleration of the body is 0? Acceleration is 0 at any time t. So, do we understand that t is equal to 0, the acceleration will be 0? At any other time, let us say t is equal to 1 second, which might be here, the acceleration will be 0. At t is equal to 2 seconds, the acceleration will be 0. At t is equal to 3 seconds, the acceleration will be 0. At every time, the acceleration is 0. So, when you try to get the graph, all you do is you join these points, and this is the graph that you get. The graph of acceleration versus time will be nothing but a straight line which lies on the timeline, telling you that the acceleration is 0 at all the times. Now, we come to the velocity time graph. The velocity of a body moving with a uniform motion is a constant non-zero value. V is a constant non-zero value. So, can we say if that value is somewhere here, let us say. If that value is somewhere here, let us say the value of the velocity is some v over here. Can we say at t is equal to 0, the value of the velocity will be that same value, and at any other time t, 1, 2, 3, 4, 5 seconds, whatever value of t you take, the corresponding value of v will be over here only at the same point, because the velocity is not changing with time, right. So, the graph in this case will look like a straight line like this, but this time the straight line will not be over the timeline, it will be parallel to the time axis, right. So, the velocity is a constant with time here. Now, what about the displacement time graph now? For the displacement time graph, do we understand it is this equation that we can take help of? At t is equal to 0, if we put t is equal to 0 in this equation, for any value of v, the displacement will be 0. The body starts from 0 displacement. At t is equal to 1, can we say s will be equal to v into 1? That will be some non-zero value depending upon what the velocity of the body is. So, it will be some value over here let us say, right. Now, let us say at the next time t is equal to 2, can we say the same displacement will become twice the displacement at t is equal to 1. So, the value will increase to some other value over here, which will be double of the initial value, in the value at t is equal to 1, and the same thing will continue, right. So, when you put t is equal to 3, v into 3 will become 3v, so that value will be somewhere over here. So, you with increasing time, you will get the displacement of the body also increasing linearly, and when you try to get the graph by joining all these points, you will get a straight line like this. This point will be over here on the line. So, what you get for the displacement time graph of a uniform motion is a straight line which passes through the origin, telling you that at t is equal to 0, the displacement of the body is 0, and as time increases, the displacement increases linearly. You can pay attention to a couple of more points over here. One is that from the velocity time graph, we can find out the displacement, because we know that there is a relation that connects the area under the graph with the displacement, right. Do we know that the area under the velocity time graph gives us displacement? We discussed this in the previous videos. So if you want to find out the displacement at any time t naught, let's say, all you need to do is find out the area under the curve, velocity time curve, which in this case will be the area of this rectangle till t is equal to t naught, right, and that will give you the displacement. Area will give the displacement here. Also, if we can find out the slope of the displacement time graph, what will that give us? Slope of displacement time graph gives us velocity. How do we get the slope? To get the slope of a graph, we need to find out the angle that the line, the graph, makes with the x-axis. In this case, it is a straight line, so it's easy to find out the angle. It will be a fixed angle theta. And then the slope of this graph will be nothing but tan of this angle theta, which we also call as m, small m, right? So by knowing the value of theta and then finding out tan theta can give us the value of velocity here, v. So from a velocity time graph, we can easily find out the displacement. From the displacement time graph, we can easily find out the velocity. Remember that the slope of velocity time graph gives us acceleration. If you look at the slope of this graph, this line is a parallel line to the time axis. So it makes an angle of 0 degrees with the time axis, and tan 0 is 0. So this makes us understand that the slope of this graph will be tan 0, which is the acceleration, right? So the acceleration of the body is 0. We are getting that from this, right? So that way we can work through the graphs also and find out our values. Next we shall discuss a uniformly accelerated motion.